All right, we've got a geometry problem here. Problem number 4. We have a regular hexagon, and the vertices of the hexagon are labeled A, B, C, D, E, F. So we call this regular hexagon A, B, C, D, E, F. And we have a center at O. The area of triangle AED is 12 square centimeters. So let me just highlight that triangle here. Actually, you know what? Let me use a highlighter. Let's just use a highlighter here. This is going to be too big. So we have this this triangle AED, and that is equal to 12. Oops, I didn't want to change this to a pen. That's equal to 12 square centimeters. Okay, AED. And the question is, what is the area of the entire hexagon A, B, C, D, E, F in square centimeters? Okay, so we're given this little piece of it, and we're asked to find out what's the area of the whole thing. Now, my hint to you would be to, I guess usually a lot of times when I see these types of problems, it's often good to draw more lines on this figure, okay, and try to break this hexagon into some congruent triangles. That would be my hint to you. And then if you've got it broken into some congruent triangles, okay. If you've got it broken into some congruent triangles, then you can count up those triangles. You can count the number of triangles that are in AED, and you can count the number of triangles that are in the whole thing, and you can probably figure out what the area of the whole hexagon is. Okay, that would be my hint for you. So congruent triangles. Okay. All right. So here's the solution. Here's the way I would look at these. Oftentimes, you know, you can draw some more lines on here. And I know since this is a regular hexagon, I know that all the sides are the same length, all the angles are the same at the vertices. And so what I'm going to do, if I divide it in half here, let me see if I can draw a straight line. Alright, so divide it in half. What if I divide it in half again? Let's see what happens. If I can get a straight line. And this is actually already divided in half here. So now I've got some congruent triangles. They don't look very congruent because my lines aren't straight, but this triangle is congruent to this triangle, is congruent to this triangle, this one here, AFO, this one. So basically you've divided this hexagon into a pie where all of the pieces of the pie are the same shape. We still, this line is kind of misleading, but you know, these triangles are all the same. But we can actually, you can see that this line here is dividing these two triangles in half, right? So what if we draw some more lines? What if we draw a line like here, dividing that in half, and dividing that in half, and we'll divide this in half, and let's divide this in half, okay? Now my lines aren't very straight, but so now we have a bunch of triangles, and we've got this AOF, and it's divided in half into this AF. We don't have this vertice label, but we have this triangle and this triangle. Okay, it's divided in half. This one's also divided in half. So we have this FOE divided in half here. So we can count all of these triangles should be congruent now because we've taken congruent triangles and we've divided them all in half. And so we could count up these triangles. Well, first of all, we know the area of AED. We're given that, and you can see that if we count up those little triangles inside it, we get 1, 2, 3, 4. So we have AED made up of 4 little triangles. Okay? So we know that, let's just write this out, AED is equal to 12. Alright, 12 square centimeters. Okay? and that's made up of 4 of these little triangles. And if we were to count the little triangles that make up the whole figure, we've got 1, 2, 3, 4. Let's just label these 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so we have 12 little triangles that make up the big figure. So we know that AED is 4/12 of the whole hexagon A, B, C, D, E, F. Alright? So we can figure out, well, let's first of all, we can reduce this fraction here. We'll get 1/3, right? If we divide top and bottom by 4, we'll get 1/3. Okay? And then if we multiply, here we have this equation here which says 12 is equal to 1/3 of the area of A, B, C, D, E, F. So 1/3 of the whole area of the hexagon is equal to 12, so I can multiply both sides by 3, and I would get 36 is equal to A, B, C, D, E, F. So we have found the answer, that the area of A, B, C, D, E, F is 36, and the units are square centimeters. Okay, so 36 square centimeters is the area of the whole thing. All right. Now, there's actually another way to look at this problem. I'm going to scroll down a little bit and try to do that. Let me get rid of some of my lines on this triangle.